Good morning. So as Boris said, it's a very good segue. Marek gave you some good overview of the serverless offering of the cloud platform. I'm going to tell you a story for the past roughly 10 years, how I started my company 10 years ago and grew the company as the Google Cloud was adding pieces, element, components to support what we needed. So thanks for the introduction. I'm Jerome Mouton. Maybe you hear my accent and you say, oh, from Germany? Doesn't sound right. Yeah, I've got a lovely French accent. I was born in France, worked in the US for several years, and decided to move back to Germany. Berlin is a very nice city. If you have not been there yet, come see us. They are hiring like crazy. I know there's a good market here as well in Sofia, but if you want to do some experience abroad, Berlin is very active in the startup space. And also co-leads the GDG in Berlin, like Boris and Sofia do here. If you want to come speak in Berlin, talk about what you do, contact me, again, meetup.com, GDG Berlin. Finally, I'm also a Google developer expert, so that's a program that was explained earlier this morning. I've been using the platform for a long time, and Google recognized that I could be useful for the community to explain my experience, to help also startup. I love to do startup engagement to help early stage startups to get launched. Okay, instead, I'm moving forward. Maybe some quick introduction. My company won't be the big focus, but I want you to get an idea of what we do to understand why the different pieces of the cloud startup, or the cloud, cloud platform was important to us. We are a communication or conversation platform. One of these several widgets you see on websites, on the right-hand side there, where you as the end user can communicate with the company. So on this web page, I said you come to Berlin to see us as a GDG Berlin, and you want to see the show from the Palace Berlin, and you have questions about the tickets. You're going to engage with the brand through the little chat window. And behind that, we have a very complex application for routing the chat to the right person, connecting you to the CRM, to the help desk, and everything that happens in the back office. We obviously have chatbots and everything, but yeah, I think it's important to understand we are doing high volume transactional type of communication. For the past 45 minutes, roughly, we are going to cover not the full cloud platform, but we are going to focus on these few elements. So you heard App Engine from Marek earlier. That's going to be one of the key focus today. We're going to talk about also some storage components, some big data analysis components, and a few more services. I want to reiterate again that as of today, there's way over 100 elements or components on the cloud platform. So obviously, with the little 7 tiles I had there, we're going to cover a very, very small portion of it. I'm a big fan of serverless, so everything I'm going to talk about, or most of the things I'm going to talk about, are serverless offering from Google. I'm going to step back in time a bit earlier than when I started SnapEngage. Before that, I was already in the startup world. I had my small one-single-person startup. And just to tell you, I'm going to interject. We're going to technology and startup tips. We're going to be a bit of mix of both. But so my first company was an LGM site, and it was mostly a consulting company. I started as I was a recognized expert on the platform from Google, and Google approached me to be a contractor for them, a consultant. And I was building this type of ads, contextual ads, that Google was making the switch from Adobe Flash-based ad to JavaScript-based ads. And I was building these ads for brands that were consuming data from the context of the page. For example, this one here for Kayak, we are looking at 2 elements. Where is the person watching the ad right now? Because we get the longitude, latitude from AdSense. And also, what are the theme of the page from contextual keywords? And based on that, I had to, in a very short period of time, find out what was the closest airport based on the location where you are. So here would be Sofia's airport. And if you're looking on a web page talking about Paris, I would have to find what are the Paris airport code. Then do a query to the Kayak travel database to find the best deal for a flight from Sofia to Paris, and display that on the screen. What I learned doing that, it was quite simple in scale, right? These services were kind of microservices by themselves, but the thing I didn't know before is marketing people that set up these campaigns, they like to go very fast. They have budgets. They want to learn very quickly by burning their budget as fast as possible. Meaning, even though, yeah, it doesn't seem complex, when they kick the campaign, we're going to probably hit several hundred or thousand of queries per second, because they want to maybe in an hour burn their budget for the day, and then have the rest of the day to analyze data to kind of re-optimize their ad campaign for the next day. Great for them, but as a developer, also managing the infrastructure, I had to plan the capacity of my servers for this spike of traffic. That means if I had 5 campaigns running, worst case scenario, I could be having several thousand of queries per second at peak, and then nothing else happening for the rest of the day. At the time, I was running on bare metal server, in a co-location center. I had a few machines in a rack, and my machines were idle most of the time, except when the campaign was running. Luckily for me, since I was contracting for Google, they had this idea of App Engine. It was a time where AWS, Amazon Web Services, was going strong in the cloud, and Google wanted to also enter the market. And they entered that in a very different or radical way compared to Amazon. Amazon started to build up from infrastructure as a service with a virtual machine and up, and Google wanted to disrupt this, and they entered with a serverless offering. Their first product, App Engine, was serverless. At the time, we didn't call that serverless, we called that as Platform as a Service, PaaS. So I got to use the alpha version of App Engine, and that was love at the first sight, because as Marek explained very well, we don't have to worry about the infrastructure. So this server fading or the disk being corrupted, none of my problems. The Google engineers were doing that. I was being charged only for the actual usage. So when the campaign was not running, no cost for me. And I didn't have to plan the capacity. A spike of traffic, the scheduler from Google App Engine would be putting more machines for me. So just want to kind of set the context. I had a very, very strong, good first experience, being luckily on the alpha of App Engine. We move forward a little bit here. So after this, this experience doing my company LGM site for gadgets, got with a friend of mine, another French guy named Jerome as well, so good team here. And we got into Techstars with a minimal viable product for something totally different. I won't go into these stories, that's not too important. Just want to interject something here that's very important if you plan to start a startup. Having done my first company all by myself, I would very, very strongly encourage you guys to not do this. If you want to start something, find someone or a small group of people that you trust, you have strong respect with, because being a small team of co-founders is so much more powerful. During my years at LGM site, some days, I was depressed, feeling, it's not working, and you have nobody to talk to, right? You are on your own, and you have to get moving. When you have a team of 2 or 3 co-founders, chances are, when you are not feeling good, the other one will be there to cheer you up, to motivate you, and the other way around as well, right? As a team, you go much, much further down. So anyway, so we got a small team assembled, very strongly motivated, wanted to break, some patterns, and but we got into Techstars, and that's another big piece of advice here. As a early or first time, or maybe second time, third time entrepreneur, having a startup incubator, a startup mentorship program helping you is very important as well. Looking back, for us, and we'll talk more about that, if we didn't go to Techstars, we would have continued our MVP, our minimal viable product, trying to make it better, trying to get more adoption. And what we've done, in fact, was a big pivot. We changed completely direction to the program, and that's thanks to the feedback we received from all the mentors. So you need this, right? As an early or first-time entrepreneur, chances are your first idea won't be the right one. So you need this feedback. It's valuable, very valuable, to be able to see what you should do next. What is the next iteration? Even if it's not a full shift, to different, but having people telling you what to do is very, very critical. There are programs all over Europe now. So at the time, we did a program in the US, in Boulder, Colorado. I'm not sure for the scene in Sofia, but I know in Berlin, there are tens of programs. Techstars is in Berlin, the Founder Institute is in Berlin, there's many of them. So you have, if you have this vision, you want to be an entrepreneur, you want to start something, you have found your co-founder on your co-founder's priority. If you have 2, 3, 4 people, try to apply to several startup incubators to see, would one of them take you in? Okay, so we got in Techstars, again, with a totally different idea than SnapEngage at the time, where the mentorship program overflowing us with feedback, and thanks to the feedback, we were able to refocus ourselves to become a customer service utility. It was named Snapabug at first, but and through this program as well, since we shifted quite the product, we started to do a rewrite, and the rewrite came at the exact right time. We were a team of Java developers, and Google released App Engine for Java. As Marek explained, on App Engine, you build on a runtime. You don't have like a Cloud Run, the full control. You have to pick one of the supported runtime. It was only Python at first, back on the day on the ads backend, and Java came. So good timing for us, lucky thing. We embrace App Engine as a beta product. And maybe another small startup tips here. When you're just starting, you need to find a way to be efficient, be in a tech stack that you and your team will be able to be proficient in, but you can take some risk as well. I'm not sure Marek mentioned it, but Cloud Run today, it's a beta product. So it's beta product kind of mean typically don't go in production with it. But you know very well that the product will evolve and be a GA, general availability, very shortly. It's probably a good time. If you feel like the Cloud Run is the right thing for you, don't be concerned that it's beta because you are early stage. Chances are, if you do a startup completely on your own, I think the stat is about 9 chances out of 10 you're going to fail. If you go through an incubator, it's typically more 1 chance out of 3, I believe, for succeeding. So your rate will be better, but the failure is part of the process. So embrace technologies that make you efficient, even though you feel like they are maybe a bit early stage. So we did that, We said, okay, let's go with App Engine Java. Let's see how it goes. And I'm going now to tell you the story a bit more in details about what component we added to what need we had at the time. Starting with App Engine, obviously. I used to talk about App Engine for an hour, 2 hours, in presentation with 50 slides. I'm going to cut that down greatly today. I think I picked 3 key elements of App Engine that, to me, are super valuable, or at least were to us very valuable when we started. The first one is, think again, you're starting a company. As I mentioned, you are 3 of you guys or girls, getting together and building a company. So you don't have much time. Time is money, or time is very, very critical, because chances are some other people, just like you, are trying to do the same thing. So going fast and first to solving client issues is very important. With the SDK of App Engine, you download something on your machine, you have everything to do local development, local testing. From this local development, local testing, you can do a local deploy back to the cloud in 1 click. Then this SDK lets you create new version, as Marek explained. You do a deployment, you say, I want to create version 2 now. You go in production with version 2 is not great, you can in 1 click roll back to version 1. So all this is done for you. Not something very complex to set up yourself if you go with VMs, but still you would spend so much more time to put this framework in place. You don't have to do that. The SDK and the deploy process I did for you. When we started as well at the beginning, we didn't have a build pipeline, no Jenkins, no Circle CI. We were 2 developers working on our own computers with Eclipse up, and we're just talking, hey, latest version sounds good to me, tests are passing. Okay, if I deploy, so yeah, deploy. Click a button, and from your machine, you're deploying to the cloud. We had Git version control, obviously, but no, no build pipeline automation. And any developers could anytime take this decision. So yeah, very convenient for sure to move forward. So as I mentioned, versioning and rollback, roll forward, extremely powerful, because as you go fast early on, you're going to make mistakes. You don't have a good coverage with test. You're going to go in production, and the customer send you an email, say, oh, it doesn't work for me anymore. So being able to do 1 click and roll back to the previously known good version, it's obviously very important. Something else they offer as well is some split version deploy. Say, you feel that the new version you just deploy seems to be good, but you have this little anxiety that maybe something that's all right. So we say, okay, I'm going to push new version only for 10% of my traffic and review the logs and see how it behaves. all this build part of the platform as well. So you have all this infrastructure for managing your development, testing, deployment, and production management that make it very efficient. There's one last part of this framework that I want to mention is when you push a deployment, we're talking about App Engine, a platform as a service for managing apps. Your apps will have static assets, obviously, and will have dynamic, servlets or Python script or Node.js code. This should be treated differently, right? It doesn't make sense that your VMs will be serving static assets. And App Engine does that for you. At the time you deploy, the SDK or the system you have on your machine will analyze what is static resources, what is dynamic code, and they're going to push that to two different systems. Your static assets will be on static hosting systems and will be pushed to the edge as soon as a request comes from a edge point of the platform. It's going to be cached there, making it very fast to deliver to clients. Obviously, the runtime part of it will be routed to a location in the data center. But again, you don't think that when you start, but it's very important for scalability, for latency. Yeah, a lot is done behind the hood. I could go on and on. There is much more to say, but honestly, again, keeping in mind small team wanting to go fast, the App Engine or serverless platform, generally speaking, really empower you to iterate fast and to get fast online. Maybe I'll say one last small thing is, it wasn't the case at the beginning, but now as well, you obviously need to be HTTPS, TLS today, you cannot do otherwise, and you need to be on your own domain, right? If you say, something.googlecloud.com, you'll be looking seriously on the market. In one click here as well, you map your domain, the platform creates for you a SSL certificate. It's not much work, but maintaining this as well in the future, they auto-maintain this certificate, they get new ones for you. It's so much little things like that done that you don't have to think about it. Okay, and I'll move on because we could be there for a long time. Auto-scaling, you heard Marek talking about that. It's magic, especially 10 years ago. It was the first time ever a platform was doing that. You cannot imagine, compared to infrastructure as a service, EC2 type AWS environment, the magic was strong. You just push your code, you don't think of anything else, and you know that some people will make it scale up when the traffic ramps up, scales down when, if you're focusing on the US market, when the US goes down. And again, you pay for what is being actually used. So that's magic. And more than that as well, the automatic scaling as automatic failover. Let's say you pick a data center in the US Central, and one of the zones data center gets a power outage or get a fiber optic cut. They will they will relocate your application to a different zone that is running for you, automatically speaking. So, and typically you don't see anything. You see a little spike of latency because obviously they have to do a lot of cold start, like Marek explained that, they don't move a warm payload. They are going to restart containers with your code to a different zone. But one more time, you do not do anything for that. It's come for free. Yeah, before I moved there, a little joke we had, in the serverless community at the beginning is what was new here. In the past paradigm, if you had an outage, let's say database corruption or I don't know, your auto-scaling script is not working anymore, you have to be all hands on deck, so try to fix it. With the serverless environment or App Engine, especially at the time, there were some outages, don't get me wrong. Of course, sometimes Google DevOps do mistakes or they have a technical issue, and we had a few outages. But when an outage hit, we're just saying, okay, guys, or teams, let's go to the movie theater, let's watch a movie. When we are done with the movie, we know everything will be back to normal. So that's kind of the different approach to it. It's mostly a joke, because if you are starting a company and you have an outage, you have to shift from doing some code to picking up the phone when customers are calling, saying, why are you done? So, or contacting Google to kind of get an ETA on the resolution. But the operational part of it is not your problem. The last aspect of App Engine I want to mention about, and it's also relevant for the general serverless platform, is the connectivity. Something I don't think Google explained well to us at the beginning, at least. We just discovered by mistake. And again, putting yourself in the context, you start a company, you are solving a problem, chances are you are not laser focused on the market. Your market is most likely the world, and you will see where the ID sticks, right? And for us, it was completely random. Obviously, we were in the US, so we had a bit more traction in the US, but suddenly Poland became super big for us. And it just became because of word of mouth. We had I think it was a doctor office, pretty large doctor office, that started using us for some of their new websites. And some people in Poland seen that and wanted to use the same technology as well. So yeah, you don't know where you're going to go. And leveraging the network from Google made this stuff very good for us, because even though we started with hosting the app in the central US, you don't have to get your user to travel from where they are to your data center, the cloud data center, on the public internet. They are going to enter the Google network as the closest edge point of the Google network, and they have edge points all over the world. That's an older map here, so it's probably even more now. And then once they enter the Google network, they're going to travel to your app through the Google network, which is very low latency. That's probably the fastest way on Earth you can go. So that's not something we planned for it, but we realized very quickly we had clients in Australia, we had clients in New Zealand, we had clients in Asia, and we never heard a single client telling us, "Oh wow, messaging is slow, with SnapEngage." No, because it was the fastest that could be. Of course, if you had data center very nearby, that could have been a little bit faster, but yeah, it's definitely tens of milliseconds faster than just having some VMs and having to traverse the internet on public internet. You still have to pick where you want your containers, or your cloud run, your app engine, or your cloud function. You pick where you want them to run. From my standpoint, the main reason for picking the location is for compliance. We have pretty large clients that are European agencies, and for them, it's completely a big no-no to get their data hosted in the US. So we open a version of our application hosted in Europe or in Germany or in the UK, based on what the needs are. But that's the main driver. It's not latency, not the time to traffic. And as I mentioned, anyway, the dynamic payload will run in one place. 3 regions at least for failover, but in one region. But the static assets are going to be cached. So all your CSS, JavaScript, images, once someone, let's say in Taiwan, access your app, if the local edge cache doesn't have your assets, the first time they will come from the US data center to Taiwan. But then for the further request from Taiwan, they are going to get the data just right there, a few milliseconds or tens of milliseconds away from where the end user is. So that's powerful by itself. All right, enough on App Engine. Again, as I mentioned, we could be talking for almost the whole day. There's so many good stuff about the platform, and it's quite a mature platform, over 10 years now of history. We're going to move on. I think the next item is the Cloud Datastore. For us, the decision was quite easy. When Google opened the alpha or beta of App Engine, they had to do a processing service, but also a database service. You cannot do a web application without the database. So they were kind of linked together in the same package. The App Engine Datastore was part of App Engine. Now they split that out. The Datastore is a NoSQL database that you can use for even different payload from VMs or anything else. But for us, again, no choice at the time. It's a NoSQL database, no SQL, right? It's a typical document-based database. I've put a little slide here with what I feel like are the pros and cons for Datastore. The main thing, again, is a platform as a service or serverless concept. You don't have to plan capacity. Like many databases, you have to say, okay, I'm going to allocate a gigabyte of data storage. Not here. You're just going to push data in there, and as you push data, they make sure that you can put more. That's pretty much how it works. The other part, as I mentioned, App Engine has a failover, in different zones in case of outages. Same for Datastore. Every time you commit an object in the store, it's going to be replicated in at least 3 different zones. So a zone, again, it's still regional. So if a meteorite hits Earth on this place, you don't have global backup, but that's still something. If there's a fire, if there is a flooding, or if there is a power outage, you know that your data are safe in 2 other buildings in the same data center. And something that may be normal now for you guys, but at the beginning of time, a NoSQL database oftentimes just had an object that you were getting by a key. But they added another level of abstraction, allowing you to have indexes and queries. Yeah, may not be super groundbreaking for you guys, but it was good at the time. There's little minuses. As of today, Cloud Datastore is still eventual consistent, meaning you push an object in there, the creation of indices for searching object by composite indexes are going to be created asynchronously. So that means when you process something, you may not be able to get it back by queries in the next half a second or second. So that's a concept you have to think about. The good news now, they're going to change the underlying layer very soon and strike this minus. That's being resolved. Other part is performance, and again, it's nothing by itself, but if you compare the Cloud Datastore to a SQL server running on your laptop, yeah, obviously it's scalable to infinity, it's multi-node, so you pay some little bit of latency for communication between the different clusters. Something you should anticipate for us coming from the world of having a big machine in a rack where everything was running on it, the database, the web server. Yes, we had to learn that it's not the same. It's a bit slower. And cost, it's a cons and a plus as well, because at first it costs nothing, right? You have free quotas on App Engine and Cloud Datastore. So when you start, it costs nothing, but the cost is linear. So as you grow, you don't have a way to kind of see the cost curve kind of slow down. It's going to be a straight line as you keep growing. But honestly, for what you get, all this fault tolerance, the resiliency, the multi-location, it's still very, very cheap compared to if you're doing that yourself with your own staff, your own DevOps, managing all this yourself. Yeah. All right, let's keep moving on. Datastore, I think we could again say more stuff, but that's a main aspect of it. If I just show you a little bit how architecture was looking in 2010, that's pretty much all. We had the Cloud Datastore as our database, and App Engine instances serving our web visitor, the chat agent in our company. At the time, we didn't have a front end. We were embracing XMPP, the Jabber protocol, which was provided by App Engine as well. And then we had a whole application for managing, configuring, seeing the stats, as an App Engine app. So keep going. I'm going to talk about cloud storage. As we grew our system, we added more users on it. We found out that it would be nice to not have the third-party JavaScript that our client put on their website being the same for all clients. Because early on, we were having our client load a resource. This resource was doing a RPC call back to our server to get the configuration, and then they were able to display the chat box. It was not a big problem, but this extra RPC was slowing down the time to render. So we said, okay, let's try to do something where we create one JavaScript library per customer, where we bundle our library plus the configuration. But for that, App Engine was not the right thing to do, because the static content, as I explained, is generated and deployed when we deploy the app itself. So we needed a place to be able to store this blob of content to be served through HTTP. And luckily for us, just at the time we needed that, that's something that the Google Cloud added. Google Cloud Storage, if you are familiar with AWS S3, that's pretty much the same, right? It's a place you store files, and they also have exposure to the web for these files. Stuff that was great for us is the authentication between different cloud products is super easy. You don't have to do OAuth. It's kind of built in when you use the cloud library from Google. From App Engine, you can make requests to the same project resources, and it does work. I'll show you the code in a few seconds. It cannot be more simple. As I mentioned, the other big plus is you put a file there, and if you put the right ACL, the file is publicly available on the web and the URL. The little thing that we would have loved would have been different is this serving URL, if you need HTTPS, they have to be on a domain from Google. It's a storage.googleapis.com. You cannot be your own domain and HTTPS unless you set up the cloud CDN, which is a bit more setup, a bit more cost. So yeah, that would have been nice to bundle in the cloud storage also the cloud CDN. Code, I won't be showing much code, but just a few lines to set up the option, get access to the service, and then you create or replace a file. And when you close, the object, it's there, it's online, ready to serve. And same as for App Engine, with cloud storage, if you pick a storage that is global, not just regional, once a user, let's say, again in Hong Kong, will access the file will be cached at the edge. And every time someone else accesses the file is there already ready to serve. So latency is as small as it can be. Okay, cloud storage, I'm moving on. I'm going to talk about cloud endpoint. As you grow a company, even more important nowadays is you will have customers who needed APIs. You cannot grow fast enough to support all the use cases of your client. And some of your more advanced clients with developer expertise in-house will want to kind of grow with you. And it's a very good thing because once people put effort to tie with your API, they are more committed to you as well. It's not as easy for them to switch, so you want to support this use case. We're a very small team. Again, at the time we started doing that, we were just 2 developers, or in fact, two people doing everything, 2 co-founders doing coding, accounting, customer support, sales, marketing. So yeah, we wanted to do APIs, but we are not expert in exposing APIs. And luckily for us, Google released a cloud endpoint. Cloud endpoint is just a way to annotate your code. You put some little annotation in Java, for example, say, I'm defining an API, and in the method, you say this method is in fact an API method. Just with some annotation, when you compile and deploy to App Engine, it was part of the building process. Now I think it's a bit separated. Your API were exposed, and there were a lot of other services like throttling of people doing too many requests. All this type of stuff you expect from an API platform was part of it. So we ran with a cloud endpoint for a few years, up to the point we grew our team and we became more expert, and we decided to kind of embrace a framework to do API ourselves. There was several limitations at the time on Cloud Endpoint version 1 that I think they resolved in version 2. And there was some benefit as well, but the benefit for us were not super strong. Like one benefit is when you do Cloud Endpoint, you can ask them to create a SDK for Android, for iOS, and for the web, JavaScript SDK, from your API. So you can have the back-end part and the front-end part extracted as well. And what we realized is for mobile developer, who focus on the mobile application, that's powerful. And in fact, I think now it's kind of built in Android Studio. For full backend developers, the benefit was not as strong, and the limitation for us was kind of a slowdown. So we are no longer using that now. We're using a Jersey, that's a JAX RS implementation for the Java people in the room here. And other people doing Spring, for example, for their endpoint, or many different frameworks. Just know it's there. The cloud endpoint has some advantages, not for everybody, most likely. I'm going to talk about BigQuery. This one will take a bit more time. BigQuery is a big data platform from Google. And they have been writing extensively about it. There's a white paper available online called Dremel, and they explain how it works. It's honestly quite groundbreaking compared to a traditional database. The data are organized in column only, and it's a columnar database, so they can do lookup very, very fast. They dispatch the queries on many tablets, and then they do they reconverge data. Yeah, I'll get into the more details in a second. But again, back to a startup view. If you are doing a startup company or a software as a service startup, especially, you will have at some point, most likely very early on, to expose what we call analytics, to kind of tell your clients using your product that they are getting some return on investment paying for your service. So they'll be able to show, or you have to be able to show them what are the value they're getting from your system. We went through several iterations of analytics. Early on, we were kind of thinking to be focused only on App Engine, and we said, okay, let's try to build our analytics system on App Engine. And it was not super great, because a NoSQL database is typically not the place or the right system for analytics. You cannot do a count. If you do a query, give me all the objects of type chat from this user, you get all the object of type chat for this user. So if they had 10,000 chats in the last month, you're going to get this back. You cannot do a count like you do in SQL, count how many chats they had. No, you have to do that in the instance, in memory. So that was not scalable. So what we've been implementing at first, we were doing counters. So every hour through a cron job, we were doing analysis on the data of the last hour and accumulating that in objects so that we could easily get counts without having to go through all the data. Because if someone asks you stats for the last month or the last year, yeah, that would have been too much data to process in real time. The UI, we were backend developers, so we built a UI with HTML divs, different size, different colors. Not the most pretty, but it was colorful. So scalability, no problem. Right? We could scale to as many requests as possible. We could count as many objects we could dream about. Extensibility was very poor because every time we wanted to add a new dimension for the stats, we had to kind of re-index everything, recreate these counters. And so we realized we had to move to something else. As I mentioned, we were convinced, and I am still completely convinced, serverless is the way to go. So we didn't want to do ourselves, a new platform with some MongoDB and all these type of things that people were doing typically for big data at the time. We wanted to find a platform as a service for analytics. And another small parenthesis here, once you are part of a program for startup, you are going to get access to many people. Other startups in the program, you're going to hear from them. You're going to hear from what other companies the different mentors are working at. So you get exposed to a network of people and companies that can be useful. And that's how we found Report Grid, an early-stage startup that wanted to tackle this problem. Building analytics for SaaS company is hard, so let's do it as a service. And that's a very nice system. Under the hood, it was extremely complex. I've put some word of the technologies at the big HA proxy, Kafka for task and Zookeeper. So yeah, a lot of complex stuff they are doing, but as a service for SnapEngage, it was just one endpoint to stream data, was streaming payload of JSON in real time, and one JavaScript library to render graphs. So powerful, but also very easy for us. What we realized, though, for them, it was not that easy because when they had outages, they were telling us, sorry, we have to rebuild the databases. So we could say it was quite a complex system. And as I mentioned earlier, don't be afraid of embracing early-stage technology or initial startup, especially when you just launch something, because you have to realize that you may not survive a year, 2 years, so take risk. We took some risk on them, and they did not survive. We did survive, but they did not survive the past year and a half. They didn't convince enough clients to make their business sustainable. They were very nice people. They gave us the source code and the README file, say, okay, we are shutting down the business, but if you want, run it yourself. And we didn't have much choice. So there's no other platform similar that we could embrace quickly. So we tried to run that ourselves. We went back, rented some servers in a data center, 32 gigabytes of memory and big rack of SSDs. We did it following a long README file, but we failed at it several times. We forgot to watch the disk capacity, and the logs flooded the disk, and one morning the database, MongoDB, was saying the disk space, and everything was corrupted. And we spent the full weekend building the system, restreaming data from scratch, and restarting. And it happened several times, up to the point we said, okay, that's not something we like to do. We want to worry about building value for our clients, not building infrastructure ourselves. So we started shopping again for our version 3 of analytics. We put a requirements list. Yeah, I won't go through this, but I wanted to have space to grow, and having something all built in if possible. These requirements led us to talk to several vendors, put some name here, but just to go fast. We, at the end, selected BigQuery from Google as a backend for the analytics, and we did visualization ourselves with these 3GGS. What's great with Google BigQuery is same as our previous system from Precog, we stream data in real time. There was a streaming API where you just make REST call to it, or make API calls if you are within the platform, and the rate limit is super high. I don't know what is this now because they keep increasing, but you can definitely stream thousands of events per second to the platform and they just ingest everything for you. And then the query side of it, it's a SQL syntax. They completely embrace the ANSI SQL, and you can do very, very crazy queries. For us, some queries would take probably 5-6 slides to show all the join and things we do. And you would kind of think when you see these queries, it's going to take hours to run on huge terabyte data sets. No, it always takes a few seconds, maybe 10 seconds sometimes. So it's still at a human scale, it's still something that runs in real time. We see some competitors that are doing analytics where you have to put start date, end date, what you want, and you click a button, and you get a message, okay, we'll send you an email when it's done. With BigQuery, we don't have to do that. We just put a little spinning wheel, and within a few seconds, we can display a graph. No matter if you selected past 10 years of data or the past week, the time will be about the same. So very powerful engine for data. The little gotcha for us is BigQuery was meant more for business intelligence. The model, the pricing, the packaging of it is meant for, in a company, you have a huge data set and you stream all your company events in there, and you can do some research on it and do some good stuff. As a SaaS platform, software as a service, we create one data set per client. So we have thousands of data sets. The key issue we're seeing right now is the API rate limits is not at the data set, but at the project level. Meaning, if we have one day, let's say 10% of the client at the same time doing queries, we may hit our query limit. And that's not a great experience for sure. So that's the one thing to think about. We thought of maybe creating one project for each client, but there is no API for automating this question of project, and even Google said that's not supposed to be this way. So that's a little thing to think about, is we always have to be careful when we add new analytics in SnapEngage to how we're going to manage the rate limits of the API. All right, I'm moving on. The new analytics, still look pretty beautiful, and this with JS is a nice low-level standard for JavaScript libraries. We're almost there. I'm going to do a quick word on Cloud SQL through the process of trying to find what's our next backend for the analytics. SQL database is typically a good system for that. So we talked to the Cloud SQL team at Google. They offer hosted and managed SQL database, both MySQL and PostgreSQL. Both of them look good. The key issue we had to face is with a SQL database, you are buying a non-scalable database. So you have to decide what the storage space, what the memory, and if you outgrow this, you have to do a migration, or you have to do some clustering of your data. So you're back in the mode where you have to think and plan ahead, which we don't like to do. We like to push data and let other people make sure it scales. So that's why we didn't select Cloud SQL. And also, at the time we started, they didn't have a machine size that was 2 times at least what we needed for processing. So if you need a SQL database, they have very strong offering. So if you just want to port existing early-stage project back to the Google Cloud, you will find that super simple. And again, it's managed, so you don't have to think of patching the OS, patching the SQL software. It's done for you. The last little word here, as I mentioned, Google entered the cloud market from the serverless approach. Unlike the other, most of the other players like AWS, DigitalOcean, all the other came from the infrastructure as a service and built up. But Google also have a very strong offering for the VM or virtual machine offering. So compute engine is there. We try as SnapEngage to avoid as much as we can to use that, because when you start building something on a VM, you are in charge of the OS patching. You are in charge of all the stacks of the runtime and everything up. So that means you have to keep in mind that you have to manage this. But there is sometimes you don't have a choice. For us, one example is at some point in the life of the company, we had a big client demand to integrate with Skype. People wanted their staff on the go to be answering chat through Skype. And we looked into the Skype platform. There was no cloud API at the time. So we built a cluster of cluster of Linux machine. On each machine where the Skype process for Linux running, we tied in a semi-API in Skype, and we made a REST API around it. So we made a cluster of cloud-based Skype. With a machine, you have full control. You can do that not easily, but you can do that. We shut down the cluster a long time ago because that was not so great. We use still Compute Engine today as a reverse proxy for some use cases where we need to exit the cloud platform on only one single IP. With App Engine today, since you have a pretty high level of VMs, for us at peak time at SnapEngage, we have several hundreds of VM running. So we cannot really guarantee what IPs will be. If you do the computation of the range of IP possible, I think there's 16 million IPs that they reserve for the cloud platform. So some clients want us to exit on one IP for their security requirements. So we do, in this case, a reverse SOC proxy going to Compute Engine machine, and then we exit there. So you will find use case for that. Even if you go serverless, sometimes you have to work around some limitations, and that's where having this is very useful. Okay, so we have 10 more minutes roughly. So I've covered all the elements I wanted to do. I want to talk about a few more stuff, so don't go away just yet. So you heard Marek talking about the serverless offering, Cloud Function, Cloud Run. What I want to say here is, I shared my story briefly that we embrace App Engine. I would say be open to other things. I mentioned earlier, Cloud Run is definitely very interesting because you have full control. You build a Docker container. Docker file is something that now is pretty standard and people know that. And you don't have a limitation on the runtime, no limitation on the tooling. You build your Docker container and they're going to scale it for you. And the pricing is still on demand. Cloud Function is something also very useful, even though you may use a mix of Cloud Function for, as was explained earlier, you have a file uploader that pushes a file to cloud storage, and you need to run a function to resize the file or do some processing on it. That's so trivial to think through a function because it's an event-based system. So having a mix of all that together totally makes sense. For us, we use Cloud Function even in a different use case. We have obviously quite a few APIs now, and our client success team has been trained to kind of use our API through Cloud Function to do some customization for our clients. So when you want something to be done to either for demoing a possibility or offering an extra service, but you don't want it to go to the core of your platform, Cloud Function is the best place to be. You can isolate things very easily and cleanly talk through API. The last icon there on the right, that's a Kubernetes engine. I don't think as a startup founder I would have been as successful with Kubernetes because there's so much more things to think about. The orchestration of the different services, you have to do much more architectural design on your own. Still a very strong platform. Many companies are embracing Kubernetes, and Google has the Kubernetes Google Container Engine or Kubernetes engine, where you can kind of offload some of the DevOps of Kubernetes to Google. So something to consider if that's what you want to do. But one more time, as a startup founder, I do not think that's probably the place you want to start. Maybe as you scale up, you may want to have more control and go there. We're almost there. I want to talk about this little green box here. That's what we call Stackdriver. When you are on a platform like App Engine, Cloud Function, Cloud Run, and even other services, I mentioned the number, where you have several hundreds of containers running App Engine payload for SnapEngage at any point in time. How do you monitor your logs for this? If you have to do it yourself, you don't SSH to the machine to see what's happening, right? So you have a platform called Stackdriver. There was an acquisition from Google that get all the information from your instances consolidated in one place, and with the data from the logging, they do monitoring for you and alerting for you. Let's say you reach a threshold, you can get a text or a notification from an app that something is wrong on your app. Error reporting, obviously. And they even pushed further. We have a cloud debugger now. So can you imagine, I'm going to show you a screenshot, but you can put kind of a breakpoint in your code that when the code reaches this line across hundreds of VMs, you're going to be notified to be able to debug that. So let's go through it. So the reporting part of it, they aggregate all the logs, and you have a nice dashboard that shows you what are the frequency of the different errors. And you can also, on the right side, you barely see it, but you can attach a direct link to a bug tracking system like Jira, so that other people reviewing can see that, oh, yeah, this stuff is bad, but it's already logged, someone's working on it. So good integration with your developer workflow. The cloud debugger, this stuff when it came a few years ago was so groundbreaking, so disruptive. It looks the same as a debugger on your ID on your machine, except you are putting the breakpoint, which is really more a watch point, not a breakpoint. You're not going to stop execution in production in cloud, but you're putting a watch point, and let's say you have an issue very, very hard to debug. You're going to be able to say, whenever the code or the runtime hit this line of code with these conditions, I want to be alerted and get the call stack and get all the variables around it. And you don't have to do anything more. You just leave the stuff up, and when it happens, you get alerted. How could you do it otherwise, right? You cannot reproduce it, and you have hundreds of machines. That's extremely powerful. They even have now a tool for profiling. So I haven't used it much yet, but you have a profiler for all your data on all your instances in the cloud. So the developer experience is getting to a point that is almost matching what we used to have on our machines before. Another tool I really love is the trace part of Stackdriver. Sometimes you have some requests taking more time, more latency than others. With the Stackdriver system, they aggregate all the logs in one place and do analysis on it. They show you some nice graphs, and see the little one with the dots. You can see the dispersion. This is the most requests for this example take about 125 milliseconds, but some of them were taking close to 500. You can click on it, and clicking on it, you get down to the other view on the bottom, where they show you, for this request, what are the different call to external services taking time, and you can get good understanding of what's happening. The trace as well allows you to compare between two deploys. You deploy version N and N+1, and they overlay the dispersion of latency across the two. That's the one you see with the orange and blue here. And you can see that this new version, is it better or worse on the statistical standpoint. So the tooling for developers is amazing, right? It's not just a platform for DevOps, but also for you to understand what your code is doing. Yeah. Last one I want to mention is, I think, hopefully I convinced most of you that, that the serverless offering of Google is very strong for backend developers, but also the Firebase platform that they got through an acquisition is offering the same type of services with more mindset of mobile developer. You do mobile application, you need a backend. Firebase is a place you want to be. And even now for web application, I think I'm considering Firebase as a good platform as well. They have the same component from the cloud platform linked through the Firebase platform. They have something that's honestly to me is more than amazing. They have their Firestore, the real-time Firebase database that now is Firestore, that let you replicate the database from the backend, from the cloud, to your device, either being an app or being a mobile application. If you disconnect and reconnect, they're going to resynchronize and get back data, and you get an event-based front-end or mobile application based on changes in the database. So it's completely magic, right? Compared to doing it with WebSocket, synchronizing packets and things. They do so much for you. And again, the main aspect for a startup founder, it allows you to abstract yourself, not as an infrastructure level, but at the application where you build value for your clients. Just want to very briefly share something. Is the Google Cloud is great, amazing, awesome, but it doesn't do everything. We have to source some services sometimes from other vendors. You heard Marek talking about Twilio earlier. We use Twilio for all the telephony aspects, the messaging. We use Pusher.com because we still like WebSockets, and they don't have a WebSocket offering on the cloud platform yet. Sending email, we use SendGrid. That's one of the most popular platforms for that. Yeah, maybe a little parenthesis. Google is a very strong offering with Google Maps, but the pricing for us was not working. They were asking way too much money for the little value we had with Google Maps, so we went with OmniScale. And want to kind of hit on the nail one more time is we could have gone with OpenStreetMap, get all the tiles, host the server ourselves, but we don't like that. As startup founders, we don't want to do this infrastructure stuff. So we found a company, it's a German company, where they provide OpenStreetMap as a service. And the cost is, we cannot do what they do for the price we pay them as a cost. It's just not the same. They do everything for us, they keep it up, they keep it updated, and we just do API calls. So again, I encourage you guys, always try to think high level. Think of your clients. Don't think of this infrastructure stuff that now is a commodity and other people do it for you. Remember, as a closing statement, so we had this architecture for the maybe 2 years of business, and now that's kind of where we are. We added many more pieces that we discussed through the process, and obviously it's still very simplified architecture. We didn't talk about AI or machine learning. We use stuff from IBM Watson and Dialogflow as well. It's always evolving, and we don't show here, but we have also a pub/sub bus for synchronization, but it was a bit hard to show everything on one slide. Yeah, and maybe one closing statement I wanted to make is, I hope you heard me say that several times, but I honestly believe that without the Google Cloud and without the startup incubator that we got in, we would not be where we are today. I'm pretty sure that without being into Techstars, we would still have spent a year on our initial idea saying, the market doesn't embrace us, but the market is wrong. We should continue, and we would have run out of our own personal saving and have to probably shut down the company. It was so instrumental to get the feedback from mentors, even if the feedback was disjointed and very broad, but at least it helped us realize that we potentially were wrong with our ideas and we had to pivot. And the Google Cloud, honestly, if we would have done the legacy way, again, of putting machine in a rack, having to deal with setting up Linux, backups, and have more machines set up it would not have been possible. I probably forgot one very important point is, you're maybe thinking but why am I so resource constrained? Startup get millions of dollars in fundings. Yeah, we went the other way. We went what we call the bootstrap way. We had saving in our pockets. We knew that we could survive for about a year with our own savings, and we didn't get investor monies. That was probably the main reason. Yeah, of course, if you get an investor giving you $1 million or €1 million, you may think a bit differently. But I still would urge you your resources are very precious. Even if you have €1 million, should you hire a team of DevOps or should you hire a team of product and developers to think at a high level? That's the difference. And the cost of going serverless versus going bare metal will be almost nothing at the beginning. It might be different when you start to scale up because the linear scaling price of going serverless will probably increase faster than going bare metal. But again, the first few years where you have the most risk of failing, you won't see a difference in price. So try to go as fast as you can. Don't try to slow you down and spend money on things that you could outsource to a leader like Google that does the best for you. All right, I've been talking for a while and quite fast with my lovely French accent. If you have questions, that would be the time now.
Yep. Let's take Jerome. We're a little bit over time, but hopefully you also bear with me that it was quite interesting, especially him sharing his own experience. We have a couple of questions in Slido. Please do have the patience for 5 minutes of Q&A at most, because we're late either way. And then we'll have a little bit of rest, and we will revise the program later on, so that we account for the delay. Could you tell us the downside of when you're working with Google Cloud Platform?
Downside, we heard several people saying there's a lock-in problem, because when you embrace a platform, you make some assumption on technology based on the platform, so moving elsewhere could be difficult. But again, as a startup, when you launch, you want to be fast, so this lock-in to me, it's a downside that it's a good problem to have. You build maybe tech debt if you want, that's what it is, right? It's just tech debt, and yeah, so no, really, honestly, no downside for it, from my standpoint.
And do you believe Google paid services are viable for just starting a startup when at the very beginning without funding?
Without funding, yeah. Maybe an anecdote here as well is we always, from the beginning, we deployed to 2 different projects, one for staging for us to test how the app behaves in the cloud for testing, and one for production. Our staging environment with a free quota was costing us 0 for the first year. 2 developers pushing to it every day and testing on it. App Engine, for example, gives you 1 instance up for 24 hours every day, and we're not using that because when we sleep, obviously nothing is used there. So yeah, cost-wise, not a problem per se. It's on camera, so I cannot share too many specific details, but maybe one thing I can share is for the first 3 years of our business running, we were paying more to our credit card processor than to Google Cloud, to give you an idea. So just getting money from our client was costing us more money than what we were paying to Google. No longer the case. This stuff kind of reversed, but so yeah, no. I think I want to say it one more time if it was not clear, is your cost at the beginning, when you are launching, having few customers, your cost will be so small that it's not a problem by itself. Yeah.
2 more questions. Hopefully we'll be able to cover them both. If you want to actually, because more emerging, use voting so that we can rate them. If you want to reduce the costs of running in GCP, which services are you to replace first?
To replace. You don't want to replace, honestly. Unless you are not happy with the service, if there is some problem of response time or technical issues, or you don't get the support you want.
It's rather the cost side, I think,
yeah,
covered in the...
You have to optimize, right? You have, as I mentioned very briefly, you have a cloud profiler now that lets you know where the CPU time is used. Yeah, look at this data and try to optimize. We always do that. When we feel like we can save $500 in our monthly cost, we are going to spend resources, because over a year, that's significant money. So optimize, keep iterating.
Will you follow Google Cloud Platform publishing new products and switching to them? How that happens?
Google?
It's not the Google Cloud Platform, like new products being added to Google Cloud. Yeah. Would you also switch to them, start using them when they get launched?
We have not switched, we embrace new product. That's what we do. A new product is resolving a new problem. Like BigQuery was a big example, right? BigQuery arrived on the platform, and we have the problem with our current data, because so we moved to it. Cloud Function also allow us to extract things from the core. So yeah, you embrace new products as they come in. Now, AI, machine learning is so big, and they are investing so much. Yes, you want to embrace that. You won't replace what you have. You're going to add more to your platform.
And the last one, why do you think Google was the better choice at the time you were starting compared to other alternative cloud providers?
For me, that was definitely the level of abstraction. 10 years ago, which not relevant to you guys now, but they were the only one offering a platform that auto-scaled, and that was doing all the DevOps for us. So that was definitely the ground, the game changer for us.
Okay, thank you once again for your session.
Thank you.
It was incredible. Sorry to everyone for the rushing through the Q&A. We just needed to have it a little bit faster, so now we have a little bit of rest. You have something more to say?
Just one thing to say is I'm here all day. If you'd like to talk to me, ask more questions or share ideas, I love working with young early stage startups, or if you even have something you want to talk about, big scale. Yeah, I'm available. My email is here as well. Don't hesitate. Don't be shy. I try to reply to every email. So yeah, please.